Good day and thank you for joining us. In today's lesson, we'll be looking at perimeter and area of 2D shapes. In particular, today we'll be looking at simple shapes. So those are going to be, as you can see below, our squares, our rectangles, our triangles, and then also our circles, which you can't see here right now. So if we're going to get straight into that, we're going to be looking at perimeter and area. So we're going to say perimeter over here and area over here. So we're just going to be looking at the different formulas for perimeter and area for all of these shapes. So we can see that we've represented certain things with, as you can see, a S. So that would mean side. So if we're looking at perimeter, we can just write that as P is going to be equal to 4S. So perimeter is the distance around the shape, okay? So if this S represents the distance of this entire side over here, then clearly, if we know it's a square, all four sides are equal, so this side applies to all of these sides over here. So we just need four of those sides to find out what the perimeter is, okay? So the perimeter of a square is going to be equal to 4S. And then the area, which is the space inside the square, this is going to be equal to, so we're going to say area is equal to side times side. Or you could say S squared. Okay? So if we're timesing side by side, we'll get this area here in the middle. Okay, so that was perimeter all the way around. That's when you're adding up all the sides. So there's 4 of S, so we say 4S. And the area is one side times the other side, okay? That's going to give you the area here in the middle. Moving on to our rectangle. Let's see here. So the perimeter for rectangle is represented by P is equal to 2 times length plus breadth. Okay? That can also be written as 2 length plus 2 breadth, right? Sorry. 2 length plus 2 breadth. Basically what this means is that we're adding this length over here and this length plus this breadth and this breadth to find the distance around the rectangle, okay? Because we have one length here, we have two lengths and we have two breadths in total. So that's why we're saying 2 length plus breadth or 2 length plus 2 breadth. Then if we're looking at area of a rectangle, we'll be doing area is equal to length times breadth. Because remember, we're timesing one side over here by the other side over here, and they'll always be next to each other to find out this area in the middle. Okay, so area for rectangle is going to be length times breadth. Now when we get to a triangle, it is a bit different, okay? But when it comes to perimeter, it's pretty much the same. So perimeter, we're just adding up all the sides lengths, okay? So that's going to be AB. So that's the line AB over here, plus BC. That's the bottom line, plus AC. So that is the perimeter of our triangle. Once again, we're just adding up the sides, okay? That's all we did with the square and the rectangle as well. When moving on to area though for a triangle, what it's going to be is half base. So what's going to be our base over here is obviously the base of a triangle, which will always be where the right angle is, okay? The right angle meets the height and the base. So it's going to be half base times perpendicular height, okay? But we'll just call it height. That height is this height over here, okay? So there's no other height we deal with in a triangle besides this height when we're trying to work out area, okay? So that was it, half base. This is our base. It's always by our right angle times height, which is always going to be this line that cuts through the triangle, and they will give us the length of the height. So now we've looked at these three simple shapes. So now we'll move on to our last simple shape, which is going to be our circle. Okay. So an important property to note about the circle is that the distance from the center of the circle to the side of the circle is known as our radius, which is why we represent it by this R. Okay. So from the center of a circle to the side of the circle, it is called our radius, that distance. Okay. And also, if we try and define the distance all the way across the circle, some of you might have heard this word before, it's our diameter. Okay. So our radius is half the length of the circle, not half the length, but I mean from the center of the circle to one of the sides. But if we had a line cutting right across, okay, let me just represent it with this. If we had a line cutting right across, that would be our diameter. Okay. And diameter is equal to 2 times our radius, obviously. So your radius is half of your diameter, okay, which is your diameter which cuts across the whole triangle. Whole circle, my bad. So now when we're dealing with the perimeter of a circle, it's very important to note that we call the perimeter of our circle the circumference of our circle, okay? So it's circumference. Okay, so our perimeter of a circle is called the circumference of the circle. And the way that we would calculate that is, we'd say circumference is equal to 2 pi r, okay? So if somebody asks you to work out the perimeter of a circle, it's 2 pi r. And if they say circumference, you know it's 2 pi r. So circumference and perimeter of a circle is basically the same thing, it's just represented by different words, okay? And then if you're moving on to the area of a circle, it is pi r squared. So now, a new thing that might not look familiar to you guys is this specific symbol over here called pi, okay? So, pi is you could consider it as a constant, okay? So pi, when we're working with pi, on your calculator, you should see the sign for pi, which you can simply just substitute into your equation, okay? So you'll have 2 times pi, you put in pi, times your radius. Say if they gave you the radius of 3. Then you put in 2 pi times 3. If you, however, are not allowed to use a calculator in your tests, pi, we generalize it to equal 3,14, okay? So, very important to note, pi is on your calculator, so you can just say 2 pi times whatever your radius is. Even here, if your radius, using radius 3 again, pi 3 squared, okay? Pi 3 squared. So you see I've just substituted in the 3 and I'll put pi in as usual. But obviously, as I said, if you're not allowed to use a calculator, use pi with the value of 3,14. Okay? So now moving on. So we've looked at our simple shapes. Let me just go back quickly. We looked at our simple shapes: square, rectangle, triangle, and circle. All of their perimeters and areas, how to work them out. So let's move on to some examples here of working out perimeter and area. So let's say calculate the perimeter and area of the square. So we already know we're working with a square and we're working out perimeter and area. So perimeter and area and square with side length 5 centimeters. Okay, so that's the side length of 5 centimeters. So all we're going to do is bring down our equation, which we know. So we're going to do perimeter first. So remember, perimeter for a square is 4s. Okay, and we already given the side length of 5 centimeters, so we'll just substitute in s, which is the side. So we'll say 4 times 5, okay, which will then give us our final answer of 20 centimeters, okay? Now moving on to area. So formula for area is going to be side times side, or side squared. So I'm just going to do side squared. Actually, let's do side times side. So we know each side is 5 centimeters, so we'll say 5 times 5. Now it's very important to look at what's about to happen here. So our area, 5 times 5 is 25 centimeters. But now when we're dealing with area, because we've times because both of them had the property of centimeters, right? Because we're timesing 2 centimeters together, what we're going to get is centimeters squared, okay? The only thing that was different here with perimeter is you could simply do 5 plus 5 plus 5 plus 5, which means you're not really timesing. But when it comes to area, you are always timesing. So that's why whenever you're working out area, you'll always have your units squared, okay? So your units in this case was centimeters, so we have centimeters squared. So important to note, when we're working out area, we'll always have our units squared. Moving on to the next question, it says calculate the area and perimeter. So once again, we identify what they want us to do. Sorry, let's get the red back. Area and perimeter of a rectangle with length 8 centimeters and breadth 4 centimeters, okay? So they've given us all the information we need, so all we need to do now is say perimeter is equal to 2 length plus 2 breadth. You could choose either to do this equation or 2 times length plus breadth, okay? So I'm going to do 2, so length is, they've told us that length is equal to 8 centimeters. We'll just put in the units here because we can, plus our breadth of 4 centimeters. So we know that that's going to give us a final answer of 12. So what we'll be left with is P is equal to 2 times 12 centimeters. Perimeter is going to be equal to 24 centimeters, okay? Now we're looking at area, which we know is length times breadth. So it's going to be equal to 8 times 4. So once we work that out, we get 32 centimeters, remember, squared. Because we are dealing with area, our units are always squared. Moving on to our next example over here. It says calculate the area and perimeter of the triangle. Okay. So let's get to it. Sorry. Okay. So we're going to bring out our formula first. Okay. Actually, let's underline first. So it says calculate the area and perimeter of the triangle, okay? And you can see they've given us nicely the drawing over here of triangle PQR. So let's get our perimeter formula out here, okay? So perimeter is obviously just going to be equal to PQ plus QR plus PR, okay? So that's just adding up all of the sides. So what we need to do is find out the lengths of the different sides looking at this triangle, okay? So the first thing I can see is that they've told us that PQ, line PQ is equal to line PR. So what does that mean? That means that PR is also equal to 5 centimeters, okay? So you see we have to source our information so that we can work it out sometimes, okay? So here at the bottom they tell us TR is equal to 3 centimeters. So from here to here is equal to 3 centimeters, right? But what they also tell us that TR is equal to QT. Since I know that those are equal, I know that QT is also equal to 3 centimeters. So that means that the entire line of QR is going to be 3 plus 3, which is going to give me 6 centimeters, okay? So you can see how easy it was for us to find out different lengths, even though they didn't give us all the information, okay? So now we can go PQ, which we found out to be 5, they gave us, plus QR, which we found to be 6. plus PR, which we found to be 5. And our final answer here is going to be 16 centimeters for our perimeter, okay? Now we're going to look at our area of our triangle. Area is equal to half base times height. So if we're going to substitute in our values, we're going to have half. So what is our base? Our base is always the line that's attached to the right angle, okay? So this is our base over here. It's at the bottom of our right angle. So our base we know is 6 centimeters long. So we'll say 6. And our height is going to be 4 centimeters long. Okay, remember the height is always this line that cuts through the triangle and meets with this right angle and the base. Cool? So now we're going to have, so 6 times 4, 6, 12, 18, 24. 24 times half, so that's basically half 24, and we get 12 centimeters squared. Remember, it's area, always squared. Then, moving on to our last example, we have calculate correct to 2 decimal places the circumference, okay, and area. Remember, circumference in a circle, that is basically our perimeter of the circle, with a radius equal to 4 centimeters and diameter equal to 12 centimeters. Okay, so when working with the circle, the main thing that we're always going to need is our radius, okay? We don't really need to bother with our diameter, but it can sometimes be useful if you want to go down that route. So moving on now, so we're going to say for our circumference, we've identified the equation for circumference to be 2 pi r. So, as you know what we're going to do, we're going to say 2 pi and our radius, which we were given as 4. So if you're doing it by way of calculator, sorry, just give me a second. You'd end up getting a final answer of, okay, wait, so we don't really need to use a calculator because if you aren't allowed to use a calculator, what you can do is say 2 times 4, right? So if you say 2 times 4, you'll be left with 8 pi, which you can have as a final answer, okay? If you weren't allowed to use a calculator, if you were allowed to use a calculator, you'd get a final answer of 25,13. But if you're not allowed to use a calculator, I'd rather go about it this way, where you say 2 times 4 gives me 8 times pi, so that could be your final answer if you're not allowed to use a calculator. Cool? Just leave it as 8 pi. So we're just leaving our answer in terms of pi, which can be seen as correct. Otherwise, do check with your teacher if they are okay with it. Otherwise, what you'd have to do is say 2 times 3,14 times 4. Okay? Because remember, we're using 3,14 as our general term for pi. So now moving on to area, we know that the area of a circle is going to be pi r squared. Okay? So what we're going to do is just going to say pi, and our radius, of course, we know is 4. So that's going to be squared. So what we're going to get is 4 squared, which gives me 16. So we can say 16 pi. But if we worked it out and we were allowed to use a calculator, we'd get the final answer of 50,27. And my apologies up here, I forgot to put in centimeters, and then obviously when we work on area, it's going to be centimeters squared, and you'll still have centimeters over there as well. Okay, so important things to note when we are doing the circle. If you are not allowed to use a calculator, you may leave your answer just as 8 with pi next to it, so that's leaving it in terms of pi, which you can also check with your teacher if they're okay with it. If not, you'll have to go about this method over here. Otherwise, if you can use a calculator, you'd end up getting this answer over here. And then in area, basically the same thing. But anyways, that is going to do it for today's lesson. Thank you very much for joining us, and I hope that the lesson was very informative.